Hey everyone, and welcome. Today we're tackling Leetcode problem 1717, maximum score from removing substrings. The goal here is to get the highest score possible by chopping out specific pairs of letters from a string. We'll break down the logic step by step. Let's get into it. So here's the deal. We're given a string, let's call it S. We can perform two types of moves. We can find and remove the substring ab to get X points, or we can find and remove by A to get Y points. The key is that when we remove a pair, the string gets shorter, which might create new ab or bar pairs that weren't there before. Our job is to figure out the best sequence of removals to get the absolute maximum score. The first thing we need to figure out is, does the order of operations matter? Let's look at a quick example. Imagine the string is Baba, and removing ab is worth a whopping 10 points, while removing bar is only worth 1. If we're smart and remove ab first, we get 10 points, and we're left with the string bar. We can remove that too, for 1 more point, totaling 11. But, what if we removed bar first? We'd get 1 point, and be left with bar. Removing that gives another point, for a grand total of 2. Clearly the order we choose makes a huge difference. That little example gives us a huge clue. It suggests that a greedy approach is probably the way to go. Let's always go for the bigger prize first. The strategy would be to scan the entire string, and remove every single instance of the higher scoring pair. Then, with whatever characters are left over, we'll scan it again and remove all of the lower scoring pairs. This two-pass greedy strategy is a perfect fit for a stack. First, we just check the points to see if ab or bar is our high priority target. Then, in pass 1, we'll use a stack to effectively remove every single one of those high score pairs. The characters that are left on the stack at the end make up our new, shorter string. Then, in pass 2, we do the exact same thing but with the leftover characters, this time hunting for the low score pair. So here's how we'll build the code. First, a little setup to make our lives easier. We'll check which score is bigger. If the score for B is higher, we'll just swap everything so that our high priority pair is always the same. This simplifies the logic a lot. Then, we'll do our first pass, using a stack to find all the high value pairs and rack up points. Finally, we'll do a second pass on whatever is left, using another stack to clean up the low value pairs. Okay, here's the complete Python code. It might look a bit long at first, but it directly follows that two-pass strategy we just talked about. Don't worry, we're going to walk through each part right now. First, the setup. The code wants to simplify the problem. It prefers to always think of ab as the high priority pair, so it checks if the points for bar, which is y for s, are actually higher. If they are, it just swaps everything. It swaps the points x and y for s, and it swaps which string pair is considered high priority. This is a neat trick that makes the rest of the code cleaner, because it only has to handle one case. Now for the first pass, where we hunt for the big points. We create an empty list that we'll use as a stack. Then we loop through every single character in the original input string. Inside the loop, we ask, is the current character the second letter of our high priority pair, like a B? And, is the stack not empty? And, is the character on top of the stack the first letter of our pair, like an A? If all three are true, we found a pair. We pop the A off the stack, add the high score to our total, and simply move on. Notice we don't add the B to the stack. If we didn't find a pair, we just push the current character onto the stack. Alright, the final step. After that first pass, our first stack contains all the characters that are left over. Now we need to process those to find the low-value pairs. So we create a new, empty stack. We then loop through the characters in our first stack, which is our intermediate string. And we run the exact same logic as before. But this time, we're looking for the low priority pair. If we find one, we pop from the new stack, add the lower score to our total, and move on. Otherwise, we add the character to the new stack. Finally, after all that, we just return the total points we've collected. So how fast is this solution? For time complexity, we make two passes over the characters. The first pass is over the original string of length n. The second pass is over what's left. In total, this is a linear operation, so the time complexity is big O of n. It's very efficient. For space, our stack can grow. In a worst-case scenario, like a string with no removable pairs at all, the stack would have to hold every single character, so the space complexity is also big O of n. So to wrap it all up, what are the big ideas here? First, we saw that the order you remove things in is the most important part of the problem. This led us to our main insight. A greedy strategy is the way to go. Always take the most valuable pairs off the table first. And finally, we saw that a stack is the perfect tool for the job. It naturally handles the check the last character logic that makes this kind of removal so simple to implement. I hope that breakdown made sense. If this was helpful, feel free to hit the like button, subscribe for more videos, or drop a comment if you have any questions. And hey, if you're feeling extra generous, there's always the Boba Fund. Keep up the great work, and I'll see you in the next one.